promised, this week we're working on a microphone preamplifier. It should say microphone preamp right there. This is another kit. This is the K1803. This is a Bellman kit. Bellman makes a lot of electronics kits, and I think this is going to be a fun one to make. This is based on the TLO71 preamplifier chip. It's really a nice, small, good sounding IC. We got our parts. I've got my soldering iron, my trusty soldering iron all warmed up. Got my solder, got my parts. We have a lot to do, not a lot of time to do it. I guess we get started. Okay, as you know, I like to make projects on these perf boards when I can, but this, I'm finding it's just, these projects are just a little too complex to do on perf board, so at least in our allotted time. So it is a little faster to use the supplied PCB board, which we'll do tonight. It also increases your chances of success a bit. If this is your first project or one of your first projects, it makes it a lot easier to get a quality result. They've done all the work for us. They've connected all the pins where they need to be connected. No stray wires. But we do have some stuff to do. We have to put some inputs and outputs. So AF in and AF out, audio frequency in and out. We have to put the potentiometer in. And we have to put the DC power in as well. So let's look at our schematic. Let's see what's going on. Essentially, we have audio in through a cap, through a resistor, into 1/2 of IC1A. And it's going to eventually get to IC1B. IC just means integrated circuit. So inside this little amplifier diagram, this little triangle, whenever you see a triangle on a schematic, we'll do some schematics 101 here. Whenever you see a schematic on, or a triangle like this, that is an amplifier. So in this case, we have 2 amplifiers here. In this one little chip, there are 2 amplifiers. It probably look more like that. 2 amplifiers. So signal comes in. It also goes out and up to IC1B. So it's just one chip, two amplifiers inside. So half of it goes straight to the top half of IC1B. The other half goes out to the negative half of IC1B. Which also, so these two things are called feedback loops. So these loops are going to give a little bit of signal back to the front end of the IC. So coming out of the IC1B through a cap and also through our gain pot. This is variable resistor 1, 220K. So this is going to control the gain, and it's going to come out audio frequency out. So that is what we're doing today. 1, 2, 3, 4, 5, 6 resistors, a number of caps. 1, 2, 3, 4, 5 caps, it looks like. Did I miss one? 1, 2, 3, 4, 5. So you remember that resistor generally looks like this. And capacitor looks like this. Capacitor is polarized. There's going to be a plus or a negative on one side. And each one of our caps has a little stripe. Caps are generally striped on the negative side. So you see the little stripe there. Here's our little potentiometer today. This is a little trimmer pot. So that's going to be VR1, although in the instructions they call it RV1, resistor variable. We've got to put 9 or 12 volts in. And I believe the TLO 71, 72, and 74, I think you can use a hot and cold power supply. I think we're just going to use a hot power supply. So this is going to be 9 volts. We're going to try and run it off a battery. I've never made a TLO 71 chip. I'm excited. This is my first one. I've made plenty of tube preamps and tube guitar amps. I made some chip guitar amps, but this is my first TLO 71. So here we go. We're going to start by putting our socket in. So remember, our sockets are keyed. So look closely. You see the little dip. Shouldn't use the term dip. Dip is what these are called. You see the little U shape at the top of the IC1. That means we're going to match it up with that. See, it matches perfectly there. I'm going to flip this over. I'm going to bend 2 pins with my wood stick. I usually bend 2 pins on opposite sides just to get it to stick inside. Then, if for some reason, I don't do them all, if for some strange reason you got that in backward, it would be a real pain to take out if you folded them all. So I just do a couple to get it in. And in fact, I might just solder that in real quick. We'll get started right away. New tip, just like I promised. That other tip was making me sad, even though it was doing a lot of good things, like some very good heavy duty soldering jobs. It was really giving the heat. But for stuff like this, you want that nice thin tip. So I try to solder away from each pin. So if I solder one, I try not to solder the adjacent one. I don't want everything to get too hot on the board. And I do want to give it a little time to adjust to the temperature. Are those last 2 joints? No, not too bad. They're okay. All right. Get these other 2 going. I think I might need my robot friend here pretty soon. Everybody watching some good television. I started watching the new version of the television show Amazing Stories, which was a show that I used to like to watch as a kid, and that was a Steven Spielberg production. I remember it from then, kind of like in the vein of family television, ET style stuff. Outer joints. Yeah, I think Letterkenny's a Hulu show. All right, we're gonna keep working. Now it came with a bunch of pins, let's see what these pins are for. I'm just going to empty my, I've got a few, I've got some input and output here. I'm going to use this input for my microphone. I'm going to use this output for the, I'll just do an unbalanced output. So just a hot and a cold, or a hot and a ground. And I'll use this for my battery. I'm just going to set this stuff out of the way. That's as I dump out my parts. So our chip, we'll set this aside for now. I believe these are all 100K except for one 2K2 or 2.2K. I believe all of our caps today are 10 microfarad, so we don't have to keep a super close eye on these. I believe they're all 100K except for this 2K2 and this variable resistor, and I'm almost positive these are all 10 microfarad caps. I didn't label that first one though, but in fact it is 10 microfarad. So I'm going to start with the resistors because they tend to be a little easier to install. And some of these are installed laterally, and some of these are installed vertically. So we'll just start with R1, 100K. Let's find it and install it. So R1, 100K is brown, black, yellow, and you can see that there. So R1 is going to be near our input. Okay. So generally, you're going to bend these before you put them in. And I think, oh, I think I misplaced my hemostats. I mean pliers. So I might run over and get those in a second. Just going to go right in there like that. I'm going to push it in. And again, once I get it in, I give it a push one direction and a push the other direction. I try not to push it in the same direction as another plated hole. So I'm going to just install all the 100K resistors right now, and then I'll trim them and I will solder them after. And again, sometimes I will clean the resistor tips if needed. These all seem to be in pretty good shape. I don't see a ton of corrosion. R2. Let's get our robot set up. Okay, R2 is going to be another lateral one. Again, away from the other circuit bits. Okay. R3. All 100K. And they're horizontally installed. I'm so used to installing parts haphazardly without bending the leads. You can also buy a lead bender, which can be handy sometimes. They're not expensive. It's just a piece of plastic. Looks like a little mold. bending away from my other points. R4, surprise, 100K. Now it looks like we're cooking here, but there's a lot of other stuff to do. I find that making things like amplifiers, preamplifiers, it's usually pretty quick to wire up a circuit, especially if you're breadboarding or doing some PCB work like this. The circuit itself goes fast. It's all the other stuff that takes time. Drilling a case, hook up wires are a big one because they tend to take a lot of stripping. I try to get wires stripped before I roll camera. Doesn't always happen, but it did today. R5. Surprise, 100K. Okay, R5 is going to be a vertical install. So we don't need to bend it in two directions, but we do need to bend it around itself to make kind of a U. It's going to go in about that deep, and then the bottom is going to be, in fact, I'll pick it up and show you real close. This is where you're here to see this up close personal circuit board, work it board. Okay, I remember a lot of gear that I've worked on has been from the 60s, 70s, 80s, and you see a lot of this vertical resistor installation in the 70s, 80s circuits because they were really packing in so many components into such a small and they don't have leads anymore. They just have like a little tiny surface mount. I don't even know what to call it. A surface mount connection. It's just a little flat piece of a flat side of the device that is covered in metal. That was R5. Let's find R6. It's going to be near the output. And R7 is going to be our 2K2. So did we lose one? Yeah, we did. R6, 100K near the output. So we're going to go all the way up and around. All right. So another way to read this number 6 here, the bigger circle is where the resistor is going to reside. So I'm going to insert it in that direction. And we're going to, again, just pull these out and away. And I'm going to solder all these in just a moment once I get R7 installed. Close, we're getting close. R7 is our 2K2. I believe that is red, red, red. Okay. That was a Casey Holford tune. Casey sent me some excellent music to stream with, which I appreciate, and I try to thank him every week. I don't know that I do, but I try to. Okay. I think that's enough of a mess that we can solder these and trim them. So let's get set up for that. I would say double check all your values, but they're all the same value, except for our 7. So let's get set up. Yeah, I did see, I think a friend in Connecticut got some snow on their porch. Okay. Just gonna go one at a time. Get these soldered up. This is why you're here. This is the important work that we're doing. So to get serious for a second, we don't want huge solder joints here. We want to, in fact, I'm gonna do this. I'm gonna do it the right way, as I know how to do it. I'm going to stabilize this board so that I can apply some pressure, not too much, but I want to apply a little bit of pressure to these joints because I want them to get a little heat, a little solder, and then a little cool. In that order. Little heat, a little solder. Too much solder can jump across a trace, cause some trouble. I generally try to shock my tip before moving on. Oh, we got my what did I call this? I called this capacitor keys music. This is for a capacitor video that I made, and it is featuring some keyboard playing that I orchestrated. I'm not going to say I played it, but some Hammondy stuff. Okay, so most of these are 1/2 of a resistor. I try not to solder both sides of the resistor together, because if you solder one side and then the other, you risk burning up the resistor quickly. So I'm going to keep moving around. Everybody see this? Okay, I'm going to move to the other side of the board for a minute. Alright, I didn't do a ton of soldering this week, but I'm feeling pretty good about this. Move this out of the way for a second. Again, I know that these are 2 of the vertical resistors, so if I do that one now, it might overheat the resistor. So I'm going to switch to this other one and give that one a little love. Okay, I think we can come back to this side. Don't want to overheat it. I've been meaning to make a chip amp like this, or a chip preamp, for a long time, and every time I do, it's always with the mindset that I'm going to save myself a couple $100. And what I feel like happens is once you add up all the parts to a DIY chip preamp, it ends up being as much as a multi-channel preamplifier. Oh, I missed one. So you can get a pretty decent mic now for not a lot of money. And it almost doesn't make sense to DIY your own, except that it's a lot of fun. And then you have this device that you made that will impress all your friends. Okay, we are ready to start trimming. Let's take a look. How'd we do? Okay. I don't think I jumped any traces. My soldering iron looks to be just the right temperature. If it's too hot, you might start lifting off some of the traces from the board, which you don't want. Okay, we can trim. So if you start to see a trace lifting off a board, stop in your tracks, turn down your soldering iron, maybe revise your technique, because it might mean that you're spending too much time on in one spot. All right, we're going to trim. So what happens here is you do end up with some sharp bits. So from this point on, I guess from the second you turn on your soldering iron, you're going to want to be pretty careful. Is that close enough? Should we get closer? Let's zoom in. Why don't we zoom in a little? Digging the vibe, coming through this handy dandy studio monitor that Luke made. I'll trim this up and I'll show you this monitor. Let's see how close we come. Last week I finished maybe a 2 minutes late for the project because of a bit of troubleshooting. Let's see what happens this week. No promises because, like I said, I haven't worked with this chip before. I've worked with dual rail supplies before, but I think we won't need one for this. I don't think I can get that one closer. All right. Now we get some sharp little stumps. That'll be great. Back to work. We should probably get these caps installed. How many do we have? I think we said there are 5. C1, 2. I didn't label those 2. I think there's 5. All right. If it's like an LM741, which I think it is, you can use a single supply. I think you can too, and we're going to try. We're going to try a 9-volt. I'm going to actually try and run it off of a strap battery. Just a 9-volt supply. Should be, I'm sure it'll be fine. Okay, let's get these caps going. C1. 10, 10, 10, 10, 10. So we're not too worried about the values. We know they're all 10 microfarads. We'll double check. 10 microfarads at 35 volts. That means this could probably take, I think these chips are rated at 24 volts, you know, give or take a few volts here or there. But remember, these are polarized. We've got negative here. Even though they're labeled positive, which might get a little confusing, you're still going to put the negative in the unmarked side because they're polarized. Push these aside. I'm going to push that one in the direction of its own trace. If you're very new to all this, these are called traces because they literally do look simply like tracing. All right, C1 installed. C2. It's a 10, so to speak. Got my value and my stripe set correctly. So that's another thing that I do sometimes is I'll push these in the direction of their trace so that I'm not jumping traces. But it's not crucial as long as you're careful with your soldering. In fact, I'm going to push this out of the way here as well because I think, yep, C3 and 4 are going to go right there. I've got a nice abrupt stop on that capacitor keys music. And I can tell it's going to be another Casey jam. Negative to the negative side. C4, we're cooking right along here. Starting to look like something here. Okay. C4, and I believe we need C5. This might be another nail biter here. Let's find C5. Where did C5 go? So double check these connections because a cap installed backward is a very common thing that happens. It happens to everybody, not just beginners, but it is a thing that will also usually stop your project dead in its tracks. All right, we're getting there. I think we can solder these in. So this is another one of those moments where you have to focus, think about your soldering technique, and just go pin to pin. We're not gonna do both connections at once. We're gonna do one and then skip to a different cap because capacitors are very heat sensitive. You can overheat them very quickly, and then you'll kind of have some trouble that you might not understand why you need to troubleshoot so hard. And it's probably because your caps got overheated. All right, I'm gonna start here. And go for one. Nice and quick. Pretty painless. Skip across the board. Sometimes I will use a alligator clip to draw some of the heat away. I'm going to do these so quick we won't need to do that, but on a bigger, more expensive cap, I would absolutely do that. Number 2, man, I've got this iron right at the proper temperature. It's at about, it says it's at about 340 on my dial. Who knows how true that is? Again, I'm skipping these caps as I go, trying to get in from whatever angle I can. I want to touch the pad, touch the lead, touch the solder to it. It's not always easy to do, and it's harder to do when you're talking about it. But I'm going to keep talking about it. skip a cap. Now I'm going to start back over with number 1. It should be cooled off enough by now. I'll refresh my tip. Nice and quick. Especially with stuff like this, you want to give it like 1 or 2 seconds, really not anymore. Can we still see this? I'm like leaned way down over here. Oh, I'm going to redo that. Did not touch the board. Oh, real quick. I'm showing you how not to do it, folks. You can keep going. I'm going to go for some smaller joints on this side because it looks like one of my joints is kind of big. Keep this tip real clean. I could put a thinner tip on, but that will take some time. I'm going to bend this out of the way. This is in the way. Clean my tip. Give yourself the benefit of the doubt. There we go. Nice and quick. Not more than 2 or 3 seconds. You get into the 5-second range with caps and you are in trouble. Yeah, not too bad. This is it. This is the meat and the potatoes of this kit right here. A bunch of 100K, a bunch of 10 microfarad caps. Another key heavy instrumentation I did for some video. What video would this have been? Oh, this would have been the Ampex preamp that I refurbished. All right, I think that's it. It's becoming apparent to me that for these kits, I'm going to need a sharper, pointier pair of pliers. Time to trim. Isabel says goodbye. Take care, Iz. Hope you're well. Could I zoom in closer? I'm not sure that I could. Is it in frame? I'm not sure that it is. I can see that it is. Sometimes I save these little scraps for jumpers. I sometimes will save the bigger scraps because they make nice jumpers for other projects. I don't save the tiniest ones, but it is nice to have some leads handy. All right, another scary bunch of pins. See if I can knock this one down a little. I think I can. There we go. Okay. I'm going to double check my joints real quick. Feel pretty good about these. I don't see anything necessarily jumping any traces. I think this one does, but I think it's supposed to. I might have to double check it. If I have to troubleshoot, I'll troubleshoot that. So don't let me forget that. Interesting. Yep. All right. Yeah, I think that's a proper joint. Okay, let's get this variable resistor installed. So remember, if we look at the schematic, here's variable resistor 1. It usually looks like a resistor with a slash through it, and that means it's got a third connection that will divide the resistor by that connection. So as you see here, connects on one side of the resistor, connects on the other side of the resistor. It also connects in a third point, and it has 3 legs. I think we can just install this, and I think we can just go for it. This is a 220K resistor. I would guess you could get away with a 250K and be just fine. You know what I'm going to do though? I'm going to clean this because this looks a little, these look a little bit powdery. I bet this has been sitting in a warehouse for a while. Just an alcohol soaked cotton swab, just to make sure it's nice and clean before we get a little solder on that. So there's only one way to install this one. Let's talk a little bit more about it. So this is the variable resistor. It's also the same as this. It just happens to be small, and instead of being able to turn it with your hand, you turn it with a tiny trimmer, tiny screwdriver. So we'll come back to that. I mean, I could just talk and talk and talk, but I feel like you wouldn't get your value. I want you to get your value out of this. Push these pins to the side. Before I cut my thumb, I'm going to just use my toothpick. I think she's been watching in silence because it's hard to type on her tablet. So if that's the case, hi, Mom. All right, I'm going to give that 10-15 seconds to cool before I go for that third one. In the meantime, I'm going to think about, it looks like we have everything but our inputs and outputs. So just double check my input here. I stripped these and I made a couple ground wires on the side here that we might need in a little while. I have to solder this ground wire, this lead on, because I don't think we'll get this ground lead into the socket. This is ready to finish up. Coming up on it, we've got about a half hour left. Make sure that tip is super clean. All right. Okay, those look good to me. We don't have to trim them. So all we have left is signal in and out. This will be in, this will be out, and our 12 volt DC in. We're going to use 9 volt. So let's do that next. Actually, I'm going to set this in. I'm going to flip it over. And I'm going to solder it right away, if it will even sit properly. I'm going to hold this over here. Oop, nope. Sometimes this helps. Put it through a different lead. There we go. That'll hold it up. Sometimes it's catch as catch can. You get something to sit properly when you're soldering it in. It's our ground. Here's our positive. Not bad. Okay, those are in. Now our input. Input's going to be a little tricky here, and output's going to be a little tricky. I think we're going to do like an unbalanced input and an unbalanced output to see, just to kind of feel it out. And I'm going to just test to see if this will even fit, because I think I'm going to be cutting and stripping wires here. Here's our output. Yeah, so that needs to be cut. This needs to be soldered and taped. Let's get this guy out of his dab position. So I'm soldering a little lead onto this ground wire, which is a thing that I do sometimes when I'm making guitar cables or mic cables, to make it easier to solder one joint to another. I'm going to give myself a little lead on this, trim it, and for you youngsters, you can just close your eyes while I strip this wire quickly, hopefully deftly, and I'm going to retrim this with some very sharp scissors, and I'm going to hope for the best, actually. Now, there was something in the manual here about the output being set from the ground. Let's just, we'll try it both ways. Maybe we've got about 25 minutes to get this thing cooking. And if we get done early, I'll let it go early. Okay. Let's wire up the output first. I'm going to go with my gut and say that ground is going to be ground. And I'm also, before I do any more damage to this cable, I'm going to try and insert both. And that looks like a nice clean insert. And I folded it under. Yeah, that's the one I'm most concerned about, is that hot conductor. Let's get that soldered in. All right. That's right. Taboo knowledge with the lighter. I try not to do it too much now. I did it like the first few videos. I did a bunch of wire strips with the lighter, and then I kind of thought about it. I was like, well, it works really well for me, but if young people see me doing it, I don't know. It's probably questionable practice. So try to keep it off camera. Then the Kelly family saying fun first, safety second. What's the other saying, Luke? I know you have another motto. Okay, that's cool. Trim off these little phrases. If I've coined any slogans over the last month or so, one of them would be no phrase, no strays. And I think I've done that pretty much here. Okay. That's right, the loop. I'm gonna tape this together so it doesn't look so janky. That's right, janky is an electronic term. It means it doesn't look great. Got my red vinyl for panache. My panache tape. If I could just count how many ground wires I've taped up, shield wires I've taped over the years with vinyl tape, specifically this red tape. I've taped a lot of wires with this red tape. All right, getting there, folks. Getting close. We'll get this in and out. We've got the signal on the ground. Now here's where it's going to get a little funny. I think I'm going to need to ground this cold connector for this input, and I might do that up here. So I'll set these back a bit because we might end up in trouble. We'll see. Maybe we'll try it without. We got so much time, 20 minutes. Have I ever finished a project so early? I'm not sure that I have. No freeze, no strays. Are we all? No, I don't think we're all musicians tonight, right? Time is a flat circle. Yeah, that's right. That. In and ground. In, ground. All right, all right, all right. Am I inadvertently doing a Matthew McConaughey impression? All right, all right, all right. Well, the reason you should buy a Lincoln. What does he do? He does the navigator. He does the marks. I don't even know what he. I don't even know what his commercials say. Well, all right, all right, all right. Okay, let's get serious, folks. What are we doing here? This is what you came here for. You came here for the soldering. I'm going to give you soldering. That's what you want. Oh. That was a big one. That was a big joint. Is it going to be the undoing? My undoing? Let's take a look. How'd it turn out? Okay. I feel okay about those. Well, there you are. Those are my joints. This is it. This is the moment of truth. I might tape this off real quick. I'm just going to connect this ground here. Yeah, that's what I'm going to do. I'm going to connect this ground here to make sure that my input is grounded to my output. Generally, when you're making a mic pre, you want to make sure your input and output are grounded. pretty much at the same point. You want all the grounds to be connected in one point. That would be like good ground practice. So that's what we're gonna work on. I'm gonna practice my good ground practice. This is gonna be a trick though, because my little dude is so out of sorts. I said I had all this time. Now I'm getting closer and closer to the moment of truth. Pressure's up. I always try to keep it interesting here. Try to keep it a nail biter. Make sure it stays. All right, I'll just do it this way. I should have from the beginning. Clamp it all together. Make my joint. I am a little worried that this clip might soak some of my heat away, but I'm not that worried. Oh, we must be getting close. This is the outro music. What is this, piano jazz? The answer is yes. I made a piano jazz song. I don't even remember what for. Okay, that's my ground. But I know that it means time's running out. All right, folks. I probably foolishly am feeling pretty good about this. I see that I need to do a few things. One is install my chip. The other is isolate this ground from the rest of the circuit. Yeah, star grounding is a good approach for grounding circuits. I like star ground, or I like a single ground with the input. Generally for mic pre's, I've done tube mic pre's in the past. I tend to construct them with a ground bus and a single point. And we talked about ground bus on this show before. Ground busing to a single point. But I've made star ground circuits that are extremely quiet and sound great as well. Okay, folks, let me grab a microphone. Let me patch in, and we're gonna try it. We're gonna see what happens. I've got a cable. Let's get a view in here. And let's get this cable taped down so it doesn't take my project with it. There we go. That should do that. Got my mic. And I'm going to need a screwdriver to trim that out. And I'm going to go grind myself real quick and install this chip. This is just like a boss fight right here. Me against this chip. I'm going to try really hard not to touch the pins. Some chips are extremely sensitive to touching the pins. I'm going to get one side in. Probably did the wrong side there. Why don't I go for the other side? Making sure that my little marking key is set up on the correct side. I'm going to push one side of this in gently while I push down with a wood pick. And I lost it. Now I'm going to push it in, and that's in. All right, chip is in, battery is almost in, output. Fingers crossed, folks. Let's see what happens. All right, battery. Battery's here. This is the moment of truth. Let me turn this excellent music down that I made. I have to turn this down at the tube amp because it's running through that studio monitor. Bum, 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 bum. Little Back to the Future for you. All right, let's see. We're gonna get some feedback. We're gonna get. Oh, I see level. I see it. I don't hear it yet. Oh, you'll just have to take my word for it, everybody. All right, coming up. Let me adjust this trimmer. See if we can't get this into feedback. So, our gain trim. I might need a smaller screwdriver. Nope. Okay, so that's off. That's full gain. Check, check, check. I got a good feeling about this. Check, check, check. There it is, folks. Wow. Is this a first right now? Has this happened before yet where I just turn it on and it suddenly works? It must be working because I hear the phone that I didn't turn off. All right, let's trim this. We'll test the gain. Give me 1 second. Why am I talking into the mic? You can hear me. I'm going to show you how to make a trimmer tool. I'm going to take a little tiny, I guess kids close their eyes again. The safety police are back. We're just going to trim this little wood pick into a wooden trimmer device. I tend to make these almost every time I make anything with a little variable trimmer pot that will fit right inside. All right, get those out of the way. Oh, that's working. Okay, so now check, 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 check. Oh. I probably shouldn't be touching that. Okay. Check, 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 check. So now you hear that it's when you turn it down and then when you turn it up, you can hear it in the room, right? All right, folks. We're done early. 7 minutes. I made up for last week. We're 7 minutes ahead. What can I do for 7 minutes? Don't worry, I've got something for you. I'll put this in a case this week. Next week, I'll show it off in its own beautiful little case. We did it. We did it. But 1 second. I guess for our outro, why don't we look at our old knobs? I mean indicators. Not so long ago, I got a bunch of very dirty indicators, and I've been sorting through them and polishing these little indicators and restoring them. And this is what we have. We currently have 4 perfect 1960s Dakaware Bakelite level indicators. And I've been polishing and polishing these level indicators to no end. Just going to town, polishing these, I don't even know what you'd call them, besides level indicators. And here's where we're at. Maybe these will go on Reverb. I have a lot of these. Maybe they'll go on a preamplifier. Who knows? I guess I'll be looking to you for some guidance on this matter. What do I do with these level indicators? I've got others. There's another one. I've got others yet. Here's another one yet. I could keep doing this all night. I'm not going to. I promise. This is the end of my level indicator spiel. Usually we choose one. I'll see you in a week. You've got 4 minutes of your life back. I'm not going to go till 9 o'clock. This works. I would say it's fixed, but it's not even fixed. It's fixed, but I didn't even have to fix it. All right, folks. Thanks, everybody, for stopping in. It's fixed.